All right, so this is our second lesson of Chapter 5. Now, Chapter 5.1, we were introduced on how a percent works, what a percentage is, how it's a comparison out of 100. So therefore, when we set them up in our ratios or in our fraction form, we didn't reduce them. But now what we're looking at is taking percentages and going to fractions and going to decimals. So when we set it up in our fraction form, we're going to have to actually reduce them now, because no longer are they going to be looked at as ratios to out of a number of 100. So all three of these numbers are the exact same information. 25% is 25 hundredths. It is also 1/4. All three of those numbers have the same value. They're just used in different ways in mathematics. That's our goal through all of this in Chapter 5, is to understand how a percent works and the fact that I can't use percentages in a math problem. So if I'm given a percent, I got to figure out, do I want to use a decimal or do I want to use a fraction? And that's going to be up to you on some of the assignments. Some assignments, they're going to say, I want you to use a decimal, I want you to use a fraction. But understanding the foundation of what a percentage is and then how to create these is our ultimate goal for Chapter 5. Understanding what we're dealing with and how to use it in any way that's presented to us. All right, so let's get into the lesson. Remember that when we first started talking about percentages yesterday, that it's always taking that number that the percentage is next to and putting it on top, because we're comparing a number out of 100 as our denominator. If we keep that in mind, it should make some of these things easy on what we're going to do. So we start with this example they first give us. It says, Carlos eats a banana, an orange, and a blueberry muffin for breakfast. What fraction of the daily value of vitamin C does each item contain? Well, then when I look at my food reference for vitamin C contents, I can see that a banana has 15%, an orange has 113%, and a blueberry muffin has a 0.5%. What do those numbers mean? Well, basically all we're going to be doing is figuring out how to change those into fractions and decimals to then look at them as our overall values. This one says to write each percent as a fraction, write 15% as a fraction to begin with. So 15%. So if we review what we did yesterday, 15%, which they have colored in here for you, then we have 15 out of the 100% that we're referring to. So as a fraction, I take my 15, I put it over 100. But as a fraction, now I have to reduce it. We're no longer doing the ratios like we did in lesson 1. Now we're actually changing it into a fraction, which means I got to reduce this if I possibly can. Well, what number will go into both of those evenly? Well, 5 goes into both of those evenly. So 5 goes into 15 and 5 goes into 100, so I'm going to reduce that down to 3/20. So I know 15% is 3/20 as a fraction. When I look at my next one, then I have 113% as a fraction. Well, that seems a little crazy, but we can have more than 100%. You know, if you suddenly got a bonus, you know, for Christmas, maybe your parents will get a Christmas bonus, so they won't get 100% of their paycheck. They're actually going to get more than 100% of their paycheck, because they're used to getting so much, and when you add on top of it, they got 100% plus extra on their paycheck. Same idea here. If they got 113% compared to what they're used to, they got an extra 13% on their check, which would be a bonus for Christmas. So when I look at it, writing it as a fraction, it's still the same idea. I'm going to take my number, I want to put it over 100. So first I have 100 to begin with. Well, what they're showing you here is I need 2 of these base 10 100 blocks in order to do this problem if I wanted to model it. I have to have 1 of them, which would be 100 out of 100. And then the second one, I would only use 13 out of the second 100. So if I take 100 over 100 and we're making that into a fraction, what does that equal? Well, 100 over 100 is the same as 1, right? We talked about that when we got into fractions. Any number over itself is equal to 1. 2 over 2, a million over a million, they're all equal to 1. So 100 over 100 is the same as 1. And then I have the 1300ths. Well, what can I reduce 1300ths down to? Nothing, right? Because 13 is a prime number. That goes all the way back to the very first week of school. And therefore nothing goes in it, and 13 doesn't go into 100 evenly. So that would just become a mixed number fraction of 1 and 1300ths. And then my second one was a decimal. Now on the decimals, as I said in chapter 4 or 5 lesson 1, we're going to have to do some extra things to it to be able to turn it into what we need to. So if I start out simply by taking the decimal and putting it on top, I'm going to keep my decimal on top because that's what's next to my percentage. So I know I have 0.5%, I make it a fraction, I'm just going to put it over 100. But I can't have a decimal in my numerator to be a fraction. So I know I have to change it somehow. So they go ahead and show you in your book how you're going to change it. You're going to multiply. You have to move that decimal one time to the right to make it a whole number. So therefore they multiplied it by 10. And if we multiply our numerator by 10, we have to multiply our denominator by 10. So that gives me 0.5 times 10, which is just 5. And therefore, when I add another 0, because I'm multiplying by 10, to the 100, I get a denominator of 1,000. Once I have 5 1,000ths, then I also have to reduce it because I have to go to the simplest form, which means I'm going to reduce numerator and denominator by 5. Because 5 goes into 5 one time, and 5 goes into 1,000 200 times. So this would actually change into the 0.5% or 0.5% is equal to 1 over 200 as a fraction form. All right, so what about explaining, excuse me. So I put this up here so we go down to this next question. It says, explain why two 10 by 10 grids were used to show 113%. So if you're paying attention, I already explained that to you. I'd like you to answer this on your own and then see if your answer is similar to mine. Remember, on these, there's not an exact wording that you have to have unless it's a definition that needs a precise definition. But I explained this to you. See if you can remember what I said, and then unpause the video and check your work. So hopefully you remember that as I was talking about this, that I said there was that addition point to it because it goes over 100 and that grid can't hold all of it. So you need two grids that were needed because the percent is over 100%. And one can only hold 100. If it goes beyond 100 and they say to model it, then you'd have to have a second grid. So if you don't have something similar to that, and it doesn't have to be as wordy, I know I write bigger sentences, okay? So, but if you still have the same gist of what I was looking for, you're good to go. And if not, erase what you have and write down the correct answer. All right, so now as we move forward, now we're going to switch and we're going to write them as decimals. All right, so this is introduced by going from fraction into decimal form. And when we take a percent and we make it into a fraction, we have 100 as our denominator. So that should be pretty easy because we know that whatever is on top and it says hundredth, we have to go out 2 decimal spaces. We talked about decimals up to this point this year. So if I start by putting the 72 over 100, and it said 72 hundredths, I'm writing it as a decimal, so I'm going to write it exactly how it sounds. It sounds like 72 hundredths, and therefore it has to be 0.72, because we always say in decimals, just reviewing decimals, the numbers together first, 72, and then the last word we say is the decimal position it's in. Our first one is tenths, our second one is hundredths, therefore I have 72 hundredths. And that does match what I have up there. So if I have 72 hundredths as a decimal, then I know 72% is equal to 72 hundredths. Another way I could look at it, I could say, well, if I have the fraction of 72 over 100, I know that fractions are division, because Mr. Barker told me that fractions are division since the very first lesson that we did fractions. We can do it that way as well. So I always take my numerator and I divide it by my denominator. My whole number of 72 would put a decimal behind it. I know I need it because I'm making it into a decimal, and the numerator is smaller than the denominator. The dividend is smaller than the divisor. So I'd add my decimal, raise it up, and then I would simply divide. And 100 goes into 7,272 times. Because 100 goes into 727 times, with 20 left over, bringing down my 0. 100 goes to 200, 2 times. Still looks the same, doesn't it? Okay. Well, the other way that I could look at it, wait, there are 3 ways we could look at these? Absolutely. And which one you use is the one that makes best sense to you. So if I have 72 over 100, then what I could look at is, I know my denominator is a denominator or a base of 10. And we talked about this. If it's a 10, it has 1 0, so it has 1 decimal space. If it's 100, like this, it has 2 zeros, so it has 2 decimal spaces. If it was 1,000, it would have 3 zeros and 3 decimal spaces. That pattern continues. When I know I have 2 zeros and I have 2 decimal spaces, then I just simply take those numbers and I drop them in those spots. So it'd be 0.72. Notice we get the same answer no matter which way I look at it. 72 hundredths is going to be written as 0.72. So 72% is 72 hundredths if you just simply count your decimal spaces that you need, if you use it as division, or you say it as a correct fraction and write it in decimal form. All of which are correct, all of which are acceptable. It's which way you do best. All right, so 4%. A little different because I don't have 2 digits to do this with. Just because it looks a little different does not mean I change how I do it at all. So I take my 4%, I'm going to write my numbers on top of my 100. Got it. Now I could reduce, but I don't need to because I'm not changing it into a fraction. I'm changing it into a decimal. Okay? So if I change it into a fraction, then I'm just going to stop there and don't reduce because I need to go down into my next step, which is go into a decimal. Once I do that, then I could look at it, as the book is showing you, as division. So I have my numerator inside, that's my dividend. I have my divisor on the outside because that's my denominator. And then I would divide, so I'd raise my decimal, and then I have 100 doesn't go into 40. So I have to hold that place value with a 0, don't I? And then 100 goes into 400 4 times. So I would have 0.04. I could look at it as, what does this say? Well, this says 4 hundredths down here. So therefore, I know I'm going to the hundredths decimal position. That's 2 over. So I just put my decimal 0.04 and I put my 4 in my hundredths position. Or I could look at it as, well, it's 4 over 100 and I have 2 zeros in my denominator, so I have to have my 2 zeros in my answer, and then I can write my numerator in that last position. Therefore, I'd have to fill in with a 0. All of which, all 3 ways you do it, is going to get you the same answer, that 4% is the same as 0.04, also known as 4 hundredths. And when we look at C, we have 25 and 81 hundredths of a percent. Whew, this one gets a little complicated, doesn't it? Well, I'm still going to start the same way because I'm going to go to decimal, and they're saying let's start with fractions. All right, so let's do that. So we're going to take 25.81 and put it as my numerator. How do I say that? I don't know, because it doesn't make any sense, does it? So if I'm going to change it to a decimal, then I know I'm going to have a whole number in my top position. My numerator has to be a whole number. I can't have a decimal. And there are 2 decimal positions in my numerator currently, so that's how I know to multiply by 100. It moves that decimal 2 times and makes it a whole number. But I also have to multiply by 100 in my denominator, which means I have to add 2 more zeros to that 100. So 100 times 100 is 10,000. All right, so this is said 2,581 10 thousandths. Got to know our decimal positions. Once I do that, then I know it's 0.2581 because that's my 10 thousandths position. So remember, my first one is tenths. That's where my dimes are written. My next one is hundredths because that's where my pennies are written. Cent, hundred, there's 100 pennies in a dollar. Then I go to my thousandths. Then I go to my 10 thousandths. All right, so I'm in the right place. I could also take my numerator and divide by my denominator. I could raise my decimal up and then start dividing. 100 does not go into 25, but 100 does go into 258 2 times with 58 left over, and then would go in 5 times with 81 left over, and then would go in 8 times with 1 left over, and then would go in 1 time, which still gives me, after dividing all that, the same answer as we have up here. We could also realize how to say that correctly, which once we moved it over, it would have been 2,581 10 thousandths, which has to be written that way. So I know that 25 and 81 hundredths of a percent is the same as 0.2581. I could also look at it in this way, where I have 25.81 and I have 2 decimal positions. Now here's where this step gets tricky, and it's not meant to be. But I have 2 decimal positions. That decimal is already there. So all I do is I ignore it because my 5 has to go in that second decimal position. So if I pick up the 25 and drop it there, then I just have to follow it with the 81. Still works the same way as before. I just got to remember there's an extra little decimal there that they have in the number. No matter which way I do it, no matter which approach I have, then I have 0.2581, which is 2,581 10 thousandths. Now, yesterday on the previous lesson, chapter 5.1, I introduced you to a shortcut on how to work with our ratios. We said if we have a denominator of 100, then we just carry the numbers in front of the percentage and put them on top as our numerator. And here are the examples that we looked at. So we get a denominator of 100 on each of those, and we just took the digits that made up the percent, set them on top, and that was our numerator. Okay? Well, on this lesson, there's also a shortcut. I prefer this shortcut because I think it's a lot easier. You ought to know me by now. After 13, 14 weeks of school, I will teach you every shortcut that I know, as long as you can be successful with it, and it will truly work mathematically. This process will always work. If I'm going from a percent and to a decimal, I have 2 steps to follow as well. I want to drop my percent sign, and then I'm simply going to move my decimal from the right to left 2 times. Always. Never more, never less. Let's look at what we're talking about. These were the 3 numbers we just converted through the 3 mathematical ways of doing it. Well, here's the shortcut. If I drop the percent sign and then move the decimal from right to left 2 times. So I'm going to drop the percent sign on the 72. My decimal is always at the right, no matter what, unless they give us 1, which is down here. But I move it from right to left 2 times. That puts it in front of the 72. I know it's 0.72. All right, so those steps again on the shortcut. I'm going to drop my percent sign, and then I'm going to move my decimal from right to left 2 times. I have 4%. I'm going to drop my percent sign, and then I'm going to move my decimal from right to left 2 times. 1, 2. I got a gap. And we've said when we do this kind of work, we're just filling in with a 0. Doesn't change the value, it holds the place value there, which I need to have. So that would say that that's equal to 0.04 hundredths. Same thing. I'm going to drop the percent sign and move my decimal from right to left 2 times. Now the thing is I don't have to start at the back because it's already there. I just simply move it from where it is. So I drop that percent sign, I move it from right to left 2 times, and now it's in front, which gives me the 0.2581. So that's the shortcut, and it's really a lot easier, and this process is mathematically sound and will always work. So if you want to do it, I would suggest you do it. But if you want to do it, you can, or you could go through the mathematical steps of the 3 mathematical ways that we can do it. But if you check in your book, those are all the exact same answers that we came up with by solving for them. All right, so what's our homework look like? So our homework will either be going from a percent to a fraction or from a percent to a decimal, which will be the next one we look at. So I have 80%. So I'm going to start by the shortcut. Put in the denominator 100, I'm going to take that 80 and I'm going to put it on top. We're good to go. However, it's no longer going to be looked at a ratio out of 100. Now I'm going to reduce it. So what goes into 20? 2 does. Yes. 10 does. Yes. 4 does. Yes. 5 does. Yes. So what's the largest one that can go into them? So we can reduce multiple times to get to the final answer, or if we can find that greatest common factor that they would both have, and looking at it sometimes mathematically is easier. Now, if you don't see the greatest common factor is 20 right here, then what you could do is say, well, I have a 0 to 0, I can cross those out, and I have 8 tenths. Then that makes it easier for you because then you can only reduce by 2s. So there's only a 2-step process. But if you want to do it in 1 step, then you have to look at it and realize that my greatest common factor between 80 and 100 is 20. Then I can reduce numerator and denominator, remember reducing happens in both places, by 20 to give you 4/5. So 80% is the same thing as the fraction 4/5. All right, 150%. So I have to put my 150 over 100. Now I could drop off the zeros and end up with 50 over 10 and reduce it by 5s. Okay? But when I look at that then, I looked at it as, well, it's just division. So instead of having to reduce and still end up with a top-heavy fraction, then if I take 150 and divide by 100, I know I get 1, because 100 goes into 150 one time, and I raise that decimal. I had a leftover of 50, I bring it down to 0, and 100 goes into 500 5 times. That's 1.5. All right. 1.5 is written how as a mixed number? Well, 0.5 is the same as a half, so that would have to be 1.5. Now, could you have done it this way and reduced? Absolutely. Showing you different ways that you can handle these math problems. Finally, we have 0.2, so we have to put the 0.2 on top. I could do some division and figure out what the name of it is, or if I do that 2-step process where I multiply and then reduce, it might be a little easier than trying to divide, figure out the name of that decimal, and then writing it correctly as a fraction. So if I take my 0.2, I have 1 decimal space I need to move it, so I know I'm going to multiply it by a 10 because there's 1 0 on it. That makes it a whole number of 2, but I also have to multiply my denominator by 10, and 10 times 100 is 1,000. So what I end up with is 2 over 1,000 as my fraction. 2 thousandths has to then be reduced. They're both even. 2 will go into both of them. So if I reduce it, then I have dividing by 2 for both of them, which gives me 1 over 500. So 1/500 is my fraction form of 0.2%. All right, so then the second part of it is looking at the percent and going into a decimal. I'm only going to show you the shortcut because it works. So I'm going to drop my percent sign every time and then move my decimal every time from right to left 2 times. If there's only 1 digit, I move it twice. If there are 3 or 4 digits, I still only move it twice. So I have 58%, I drop my percent sign, I move my decimals from right to left 2 times. Remember, it always starts at the back if there's not one given. I move it twice, it goes right in front of the 58, so I know I have 0.58 or 58 hundredths. Same thing with the 9%. I'm going to write my 9%. I'm going to drop my percent sign. I'm going to move my decimal from right to left 2 times. Now right to left 2 times leaves me a space there, doesn't it? So I have to fill in that with a 0 and hold that place value. So I have 0.09, which is the same as 9 hundredths as a decimal. All right, so that's all there is to the lesson. It is a little bit longer than yesterday's, but there are so many mathematical ways that we can solve for them. I wanted to show all of them, but I also wanted to include, here are just the shortcuts to being able to do them and always be successful with it. You can use those shortcuts from now until you're old like me at 47. It'll always work. Now, as you're working it, if you have questions, you can come and ask me when I'm done working with the people in the back. But keep in mind, you do have some classmates that this is going to be easy for them compared to some of the other things. You're more than welcome to ask them if they are wanting to help. And hopefully everyone wants to help each other so that every person can be successful. So your homework, 279, 2 through 14, and then 280, questions 1 through 6.